This is number 64, part A. The question is really just asking us to determine the number of moles of a particular compound given a starting mass. And we have 55.98 grams of CF2Cl2. In order to begin, we have to determine the molecular weight. And that molecular weight is going to be in terms of grams per mole. And so in order to do that, we need to know all of the elements that are present in the molecule. We also need to know their atomic masses. And so we have, for instance, chlorine. Chlorine has a mass of 35.45 grams per mole, and there are 2 of them there. So we have a total mass contribution of chlorine to be 70.90 grams per mole. Fluorine has a mass of 19.00 grams per mole, and there are also 2 of them, and so its contribution to the molecular weight is 38 grams per mole. Carbon, 12.01 grams per mole. There's only 1, and so that is its contribution to the overall molecular mass. We add all these up, and we get a value of 120.91 grams per mole for the molecular weight of CF2Cl2. This is really a conversion for this molecule. It allows us to go between grams and moles of this particular compound, CF2Cl2. And so for the second half, to answer the question, we start with the mass that we were given, the 55.98 grams. We use our molecular mass, saying that for every 120.91 grams of CF2Cl2, that is 1 mole of CF2Cl2, and that'll tell me how many moles I have. I have 0.463 moles of my CF2Cl2 as a result of having 55.98 grams. So we sum up all the atomic masses for the elements found in the molecule. We multiply them by the coefficient or ratio that they are in with regards to the molecule. Sum up all those masses to get the molecular weight for the compound, and then use that as a conversion factor to go from mass to moles. That's number 64, part A.